Okay, so this is the review. This will be the odds recording. And so if you're looking for the evens recording, go look somewhere else. It'll be posted in the same spot. And that way between the two of these things, you'll have all the answers if you need to look them up. So we did one yesterday in every class, so I don't need to redo that one, other than maybe just show the answer. And I guess remind you that there were two ways to do number one. Right? You could do it the transformation way, but you could also do it the get one fraction way, and then answer the properties and then do the graph. Or you do transformations, get the graph, and then get the properties. So, I don't know, several ways to go about. 1 and 2 was the same type problem. So, kind of up to you. If you recognize it's transformations and want to do that, that's fine. If you want to work them all the same, and so you get the common denominator and turn it into a one fraction, then you can do it that way. So, up to you. Okay, again, number 2 is the same thing. So then we get to number 3. Is 3 eligible for the transformation method? No, definitely not, right? Like, there's no way to know which way, left, right, up, down, like that. That's not going to work. So what should we do first for number 3? Factor the top and bottom. And with a 2, in fact, a negative 2, I'm going to factor the negative 2 out first. So x squared minus x minus 2. And then factor what's left. So that would be x minus 2 and x plus 1. Yeah, and then in the bottom, x plus 2, x minus 2. So probably the thing you notice right away is that there's a hole. I heard some of you mention that. Just be careful. Yes, there's a hole at 2, but let's take these at least somewhat in order. What can't x be? 2 and negative 2. And let's see, you said there's a hole at... So if I cross out x minus 2, where does that put the hole? Yeah, 2 comma, plug it in and see what you get, right? But whatever factor canceled, that's what leads to the hole. So we'll plug 2 into what's left. So let's see, that would be negative 6/4, also known as negative 3/2, or negative 1.5. So over 2, down 1.5, there's a hole. Nick, how about vertical asymptotes?
X equals negative 2.
Good. X equals negative 2. And again, some people fill out all the information and then put it all on the graph. I like to put it on the graph as I go, because I think it helps me catch mistakes. You know, on those rare instances where I might make one. Horizontal and slant, that's what happens as x goes to infinity. So, Jack, when x gets really, really big, what are we approaching here? What's that?
We're on 3, right?
Yeah, number 3.
When x gets big, we get close to negative 2.
We do. How did you know that?
That's what's on my graph.
So somebody help us out here. Where does y equals negative 2 come from? Yeah, it's the equal co problem. So I'm looking at negative 2x squared and x squared. And when x is really big, the other stuff wouldn't really matter. And so those would reduce to negative 2. By the rhyming method, it's the equal co problem. Top no, bottom O, equal co. So we grab the ratio of the coefficients, y equals negative 2. right, x-intercepts. Ryan, how do I find an x-intercept?
Set y equals 0.
Set y equal to 0. And Cody, what makes a fraction equal to 0? The top being 0 or the bottom being 0?
The top.
The top being 0. So I really don't even care what's in the bottom, because the only thing that's going to make the fraction 0 is the top being 0. So -1 would be my only x-intercept. And we're about to find our y-intercept, but I can look on my graph and have a pretty good idea of where I think it's going to be. It's going to be around -1-ish. But Liam, how do I find it? How do I find it, the y-intercept? I don't want to set the bottom equal to 0, because that would tell me what x can't be. To find x-intercepts, we set y equal to 0. So to find y-intercepts, we'll set x equals 0. So we plug 0 in for x, probably in the original form rather than the factored form. Either would work. But in the original form, the zeros wipe things out pretty easily. And you end up with 4 over -4. And so Cooper's guess was exactly correct. 0, -1. So feeling really good about the right-hand side. I got 3 nicely placed and spaced points here. What about on the left? Do you think it's above or below the horizontal asymptote? Why do you think it's below? Because it usually flips. Is there another reason why you think it's below? One more reason, but Entree?
We already found all the x-intercepts.
Good. We already found all the x-intercepts. And if this was above, there'd be another x-intercept. So pretty sure it's got to be below. I've also told you we need 1 point per branch, so I've got to pick something over there anyway. Probably -3. Probably plugged into the reduced version of the equation here. So -2 times -2, I'm plugging in -3 here, over -3 plus 2 is -1. So all that put together is -4. So -3, -4, that looks like where we thought it would be. 1 point is enough. If you're concerned and you want to check x equals -4 and -5 and -6, go for it. But I'm feeling pretty good about that problem. Questions on number 3? For the 800th time, please be careful factoring. Right? Because what happens if you factor wrong? Everything's wrong. I mean, basically. Again, I'll try to be nice and give some partial credit for you working the wrong problem, but I'll take off a chunk, because, come on, if you can't factor at this point, what are we doing? All right, number 5. Speaking of factoring, this is nice. They sort of partially factored the bottom to help us out. X plus 3, x minus 3 in the top. In the bottom, there's already an x plus 3, so I see a hole already, although I'm a little hesitant to mark it out because I don't want to forget to include it as a domain issue. X plus 2, x minus 1. Right, so, Adeline, what's my domain issues here? What can't x be? So, domain is what would make the bottom 0, because we can't divide by 0. So you tell me what would make the bottom 0. What value of x would make that factor 0? Good. And what value would make that factor 0? Good. Kennedy, do we have any holes? And what's the x value of the hole? So -3, because that's the factor that cancels. Carson, how do I find the y value of the hole?
You can plug it into the x values.
Good. Perfect. Yeah, we'll take that -3 and plug it into the x values that are left. So -6 over, let's see, that would be -1 times -4. That would be -6/4, also known as -3/2. So -3, -1.5 for the whole. Dantre, how about vertical asymptotes? Yep, x equals -2 and x equals 1. Again, everything that you list as a domain issue is either a hole or a vertical asymptote. Never both. If they cancel, it's a hole. If it doesn't cancel, it's a vertical asymptote. And for this lovely problem, we have 2 vertical asymptotes. And I think we can say we've done enough problems with 2 vertical asymptotes to know that something weird probably happens in the middle. Sometimes it looks parabola-ish, and sometimes it looks x-cube-ish. But we don't know. We'll just have to keep going and see what happens. All right, Ethan, as x gets really, really big, what is our y value approaching?
I don't know.
So which is bigger, the top or the bottom, in terms of degree? All right, well, let's slow it down. What's the degree of the top after we cancel out the x plus 3's?
1.
And what's the degree of the bottom?
1.
X plus 2 times x minus 1, that's x squared. So that's degree 2. No. If we plug in something really big, and we have x plus some other stuff, and x squared plus some other stuff, which of those is going to get bigger? The denominator. And what happens when we divide by a really big number?
It gets like smaller.
It does. In fact, it gets smaller and smaller, and it gets closer to 0. That's the way to think through that problem. What's the rhyme that goes with this problem? Bottom O. Right? Top no is a slant. Bottom O, meaning if it's bigger on the bottom, it's 0. That's this one. And that last one was an equal co problem. But what we're looking at, Ethan, what we're looking at is the degree of the top compared to the degree of the bottom. So if it's bigger on bottom, if it's heavier on bottom, then it's going to head to 0. If it's heavier on top, then it'll be a slant. And if they're equal, that's when we do the coefficients. All right, so there's y equals 0. X-intercepts. Serena, how do we find x-intercepts? Set y equal to 0. And what would make the fraction be 0? The top. So what value of x? Just 3. Again, it doesn't matter what the bottom is for the x-intercepts. Reese, how about y-intercepts? How do we find a y-intercept?
You make the x as 0.
Good. So I can do that in the original, but that looks kind of complicated, so I think I'll do it in the factored form. I plug in 0 for x, I get -3 over 2 times -1. So that would be 0, 3/2. Oh, this is going to be an ugly one, I think. So an x-intercept of 3, 0.
I was confused because it's on the asymptote.
But it can be on an
Horizontal.
It could be on a horizontal asymptote.
But I thought that when it's
0, comma 1.5. Okay, so definitely something weird going on, such is the case with these when there's more than one vertical asymptote, because I don't really know which way it's going. I'm pretty sure I know what's going on the left, right? Because I have all my x-intercepts. I'm close to a asymptote, close to both asymptotes. Oh, I didn't hit that hole very well, but you get the idea. So what do we think is happening when we cross this vertical asymptote? It's probably going up. I suppose I could plug in -1 if I wanted to, but I think it's going up. You know what? Let's get another point on the right-hand side before we, right, because that one's on the asymptote, so that doesn't really help. So let's try x equals 2, and that'll help us know which way we're headed here. So plug in 2. 2 minus 3 is -1. In the bottom, 2 plus 2 is 4. 2 minus 1 is 1. So -1/4. Okay. So we're headed down. We can go up here, like if I plug in 3 or 4, I think I'm going to be positive. But I'm never going to cross the x-axis again because I already located all my x-intercepts. So I'm probably going to go up a little bit and then head back toward the x-axis. If that bothers you, if that seems annoying or weird, then plug in something else. 1, 2, 3. Let's plug in 4 and see what happens. 4 minus 3 is 1. 4 plus 2 is 6. 4 minus 1 is 3. 1/18. So positive, but barely. So now, do we think the middle portion, based on what we now know, do we think the middle portion is going to be a U or a cubic looking thing? A U. Why do you say a U? I agree with that.
because they're both going down.
Because these are going down, so both of those are going to be going up. I suppose we could check x equals -1, but no need to. I also know I don't have any x-intercepts, so that would be another reason I can't have a cubic looking thing. So yeah, that was a weird one. Those ones with 2 vertical asymptotes, they can get tricky. Questions on that one? All right, number 7, and final for this video anyway. Write the rational function. Okay, these are the Jeopardy questions where we start filling things in and sort of hope it all works in the end. Rational function. Known zeros. So where are the known zeros going to go? What makes a fraction equal to 0? The top or the bottom? The top. So what factor would make -1/2? 2x plus 1 and x minus 7. So we got those taken care of. Horizontal asymptote at y equals 0. So what kind of problem has a horizontal asymptote at y equals 0? Yeah, one that's heavier on the bottom, more factors in the bottom, a bigger degree on the bottom. So I don't have that yet, but I need to get a bottom O type problem. And then lastly, vertical asymptotes. Carla, where do the vertical asymptotes come from, or where am I going to put those factors? Good. So, oh, this messes some people up. Logan, what's the factor that leads to x equals 0?
Just x.
Good, just x. And then x minus 4 and x plus 5. Got those. Okay, the one I wasn't sure about yet was the horizontal asymptote of 0. Do I have that now?
Yes.
Yeah, because Ethan, what's the degree of this denominator?
I'm really sick. I don't have my glasses here. Let's see. I'm just waiting for my paper. The top or the bottom?
The degree of the denominator.
3.
And the degree of the numerator? 2. So it's a bigger on bottom. As x gets really big, we would be headed to 0. Matched all our criteria there. Okay. I feel like many of you are good because we reviewed this for a couple days, but some of you still need to keep working on this because you're not there yet.